I'm going to talk about an exponential function being transformed, and I'm also going to talk about its asymptote. So the first thing I'm going to do is make a table of values so that I can graph the function g of x is equal to 2 to the x minus 4. So it started out as f of x equals 2 to the x. That's what it says in the last sentence. That would be an exponential function with a base of 2. Putting that minus 4 on the end to become g of x means that this has a transformation down 4. Anytime you're adding or subtracting a number to the function, you are either going to move it up or down. So the minus 4 means that the function pictured in the graph is just going to shift down 4. But instead of me just making a rough sketch of that, I'm going to make a table of values. So you can plug in whatever you want. I'm going to plug in -2 through +2. So doing that, every single x becomes -2, -1, 0, 1, and 2. Now I want to point out what happens with those negative exponents. If you have 2 raised to the -2 power, what you can do is deal with the negative separately from the 2 in the exponent. What the negative does is it flips the base. So 2 being raised to the exponent actually becomes 1 over 2. That's going to happen in my first 2 lines there. So instead of 2 to the -2, it becomes 1 over 2 to the +2. Same with the second one. I have 2 to the -1. That really becomes 1 over 2 to the +1. So 1 over 2 squared, you're squaring both the numerator and the denominator, which makes it 1 over 4. And then 1 over 2 to the first power is still just 1 over 2. So you have 1 over 4 minus 4 and 1 over 2 minus 4. Hopefully the rest of these are a little easier. 2 to the 0 power is 1, because anything to the 0 power is 1. 2 to the first is just 2. Then we're subtracting 4. And then 2 squared is 4. So that should be your table of values. Go ahead and pause the video if you need to catch up and follow my work there. But I've got a bunch of XY points now. -2, comma, -3.75. -1, comma, -3.5, and so on. So I'm going to go ahead and put those on the graph. So you can see already that the function that was there has already been shifted down based on the points that I just put. So before I actually connect these, I'm going to talk about what is called the asymptote. An asymptote is really an imaginary line that the graph gets very close to but never touches. Think of it as a boundary. It can never touch it, it can never cross it. So going back to the original, the red graph that's already on the plane, f of x equals 2 to the x. Notice that on the right-hand side, this function is growing exponentially. It's going up forever. Nothing's really going to stop it. However, on the left-hand side, it's not increasing as quickly. It starts to increase quickly as we move to the right. But on the left, it's hard to see because it's not like I have the entire graph going on forever here. But what's happening is it actually gets really close to the x-axis without actually touching it. You will never have a y value of 0 coming out of this graph. You can plug in any number for x, and 2 to some power is never going to give you 0, which means that graph is never going to touch a y value of 0. So we have what's called an asymptote there. So I have this dashed line on the x-axis. That would be the line y equals 0. It's going through the y value of 0. That's the boundary for this function. It's never going to cross that line, so we call it the asymptote of f of x equals 2 to the x. Now, back to my transformed function. If I moved the function down 4, the asymptote has to move with it. So this time, my asymptote is y equals -4. The whole graph has been shifted down, so these points that I just drew, once I connect them, will never cross y equals -4. So that's how I drew it. Now, y equals 0 is no longer an asymptote for the transform function, so obviously I can have it crossing through that. So for the new function, it can't cross through y equals -4.